Okay, then this assignment can be a pain in the you-know-what. It's not like hard math, it's just tedious, okay? What you have is a shaft and a hole, okay? Shaft goes into the hole. Now these are the diameters, these little arrows, that's how wide across. Now obviously the hole has to be wider than the shaft so that it fits into it, okay? So this is number one, is all one problem, okay? NA means we don't put anything here. Now the diameter for B is bigger and the hole's got to be bigger, so that's B and that's A. Now it's kind of flipped around on the assignment. We're going to go look at that. Here A is bigger, so A is the hole, B is the shaft. Okay? That's how that works. So they're kind of flipped around. But the math doesn't change. Okay, so boss says he wants the diameter of the shaft to be this right here, but I'm allowed to go over it by 0.0010 and under it by 0.0030. Okay? So I take 1.4580 and I add to find the maximum. You'd add, that's kind of a given. That's the basic, but you're allowed to go over it. 1.459. And then I'm allowed to go under it by 0.0030. So the maximum and the minimum is right here. That's for the shaft. Okay. Now diameter B is the hole. Okay. So you take your basic 1.4610 and you add 0.0. No, I didn't mess that up. That's what the book said. Okay. And then to find your minimum for the whole part, you minus 0.0010, okay, 1.46 even. Okay, maximum clearance, okay, now, obviously we said the hole has to be larger than the shaft, okay. Maximum clearance means maximize the space. Well, here's how you find the max clearance. You're going to have to subtract, but to maximize the amount you get, you take the highest max minus your lowest minimum. Okay, you're basically maximizing the difference. To find the minimum clearance, you take your lowest minimum minus your highest maximum. Oh, excuse me, that didn't make any sense. My bad. Okay, this one's right. Okay, excuse me. You take your highest minimum minus your lowest maximum. Okay. So highest max minus lowest minimum, and then the highest minimum minus the lowest maximum. I know it's a little bit confusing, but you'll see how it'll make sense when we do the math. Okay, look at your two maximums. What's the highest one? Well, obviously it better be for B, because that's the hole it has to fit into. Minus your lowest minimum. Okay, lowest minimum better be A, because that's got to fit into it. Minus those, and you get 0.009, 9 thousandths of an inch. Now take the higher minimum minus the lowest maximum. This minus this. By the way, this is bigger than this. 114456. I don't give a crap that has 3 decimals and that has 1. 6 is bigger than 5. You compare them. That's bigger than that, so it's 1.46 minus 1.459. See, if you do it the other way, you get a negative. That doesn't make any sense. Okay, there you have it. Okay, next one. It's basically the same cookie cutter process throughout. Okay, right there. Diameter A, 0.9345. First I'm going to add 0.0010, 0.9355. Then we go back 0.9345, okay, minus 0.0030, 0.9315. Minimum, maximum, that's for the shaft. Now the hole, I better get bigger values, okay? So 0.9365 plus 0.0030, 0.9395. Then 0.9365 minus 0.0010, 0.9355. Okay, remember, take your highest maximum, better be here for B since that's the hole, the dot should be wider, okay? The hole it has to fit into should be the wider, okay? Minus your lowest minimum, okay? So 0.9395 minus 0.9315, 0.008. Now take your higher minimum, okay? Now compare, oh, they're the same, okay? Higher minimums here, lowest maximums here. You get 0. You can have a clearance of 0. It would be like wedged into it, okay? Be kind of weird, but it will work, okay? Next one, 2.1053 plus 0.0010, 2.1063. Then you take your 2.1053 and minus 0.0030, okay? 2.1023. So that's the shaft. That's the widest it can be. That's the most narrow it could be. Now the hole. These are tolerances here. You have 2 though, because 2.1108 2.1068. Okay, higher maximum. Guys, you got to compare the places. 221101. So that's the higher maximum. Okay. Lowest minimum. 2211006. Okay, there's your lowest minimum. 2.1108 minus 2.1023. 0.0085. Okay. Then you basically subtract the other two. Okay. Highest minimums here, obviously. Lowest maximums here. 5/10,000ths. Okay. I'm not doing number 5 because that's I must have typed something wrong. I did that earlier and it was weird. Okay. Okay, 0.4970. Now the maximum 0.498. No, I did that wrong, my bad. 0.4941 plus 0.0010. There we go, 0.4951. Minus 0.0030. 0.4911. It's the highest, the lowest. That's the shaft. Now the hole's going to be wider for both of them. Okay. And remember, it has to clear the shaft. Okay. Can't clear it unless the shaft's as big or bigger. 0. Did I do that right? Yeah, I did. 0.5. Okay. 0.496. Guys, I know that only has one decimal place, but that is a higher maximum than that. 0045. I don't care about the rest. As soon as that's bigger than that, that's your highest maximum. That's your lowest minimum. Okay. 00449916. So that one's lower. Okay. 0.0089. Then back the other way, okay? Remember, that's always going to be wider, but that's the minimum, that's the maximum. So to minimize your clearance, you take the lowest that pole B can be minus the highest, the maximum that A can be, okay? 0.4951. 0.0009. Yes, that is higher than that. Zeros by a lot. 0.000080 makes sense. Doesn't matter what has more decimal places. Okay.